Hello everyone, we'll now start the videos for quantum physics short structured questions. Okay, so question number 1, we are given this photocell over here, right, and we are given the graph, right, corresponding to it. So let's read the question slowly. It has two metals, E and C, right? This E, that's C. E is sensitive to photons, and by radiating it with a certain frequency, right, greater than the threshold frequency, the photons are emitted towards the collecting plate. Emitter measures it. So this is the usual setup that we have, and this graph that we have over here is also the usual graph that we would expect. So the first question they ask, is define the threshold frequency, right? Define the threshold frequency. This is bookwork, right? This bookwork. The threshold frequency, right, is the minimum frequency of light that can cause photoelectrons to be emitted from a particular metal surface. So note that the threshold frequency always corresponds to a particular metal surface. Different metal surface will have different threshold frequencies, right? So this is question number 4A, pretty easy. For B now, they're asking, with reference to photoelectrons, explain the significance of the sloping section of the graph for negative values of potential difference. So essentially they're asking you, hey, why is the graph sloping downwards here, and what does that mean? Okay, so the sloping graph means that the current is decreasing when you're increasing the potential difference across it. We know that the stopping potential comes about when all of the kinetic energy, or rather the kinetic energy of the highest electron, is not enough to overcome the electrical potential energy, right? That's what you have for stopping potential, right? That's what you use to measure stopping potential. So here, when you increase the potential difference, what you are doing is you are preventing electrons from reaching the collector C. If you increase the V by a little, you are stopping the least energetic electrons. You increase it by a little bit more, you're stopping the next bunch of energetic electrons. Alright, so let's look at how we phrase it up. For negative values of potential difference, where C is negative relative to E, electrons will lose kinetic energy and gain electrical potential energy as they approach C. Right? The slope simply means that the electrons have different kinetic energy. It has a range of kinetic energy. Right? The current decreases because more and more photons are unable to reach C as their Ke are fully converted to EPE even before reaching C. Okay? This is a pretty involved question for 1 mark. So to fit your answer into 2 lines, you could just use the highlighted parts. But I decided to write a bit more so that you can learn better. Next, part C, a calculation question. Use figure 4.2 to determine the maximum speed of the electron. So to find the maximum speed, right, strongly suggest that we just need to read this value, and we need to read this carefully because the minimum value is actually not at 2.0 but seems to be more at 2.2 V, right? So let's look at the answers. The stopping potential, if I read off the graph, is 2.2 V. That gives you 1 mark. Next, we relate the kinetic energy, half mv square of the electron, to the electrical potential energy, EVS. Rearrange, you get this equation. Sub in the values. Typing in the necessary values, you get your speed, right? So 3 marks. Speed of 8.8 times 10 to the power of 5 meters per second. Next, part D, the intensity of the electromagnetic is halved, but its frequency is kept constant. This suggests that the number of photons coming in is halved. If you halve the number of photons, what do you think will happen to the current? Right? So sketch the new IV characteristic. Right? Let me sketch on this graph, right, the new IV characteristic. So there you go. This is the answer, but I didn't sketch it together. I'm going to draw it again to show you. But here are what you need to have. Number one, first you need to label the stopping potential, and it must be the same as previous, or rather you should join it up. Right? Join up the curves such that they are the same. Number two, because the intensity of photons is half, that means the number of photons is half, the current must be halved. Right? That means this straight line here is at 3.5. Next, your curve must not intersect the previous curve. Right? So if I draw them together, try to be a little bit careful here since the picture is a little bit small. 3.5 is around here. Oops, it's hard to use the tablet controls. Yep, there you go. You should have something like this. Alright. If you put them together, that's what you get. 3 marks. Right, and that's the end of question number 1.